3, 4, systems and equations and 3 variables. So now we're going to solve in a system that has 3 variables. Now I'm sure if we talked about this, but we used to having a normal 2D system, XY system. Now we're going to do a 3 variables XYZ system. So let me show you a little bit first. So we all know that XY is an XY graph, 2D, an X and a Y. Here's a 3D graph, 3 dimensions. Ooh, let's try to get, there we go. Let me move that over. Okay, so that's a 3D graph. Now it looks a little funky there, but the way this works is this is X, this is Y, and this is Z. And really, let me ignore this. Let's fill this out real quick. Okay, it's kind of supposed to be it's hard to see. It's kind of supposed to be a box. The general idea is X, Y, Z. This is positive values, and then if you kind of fill it out, we kind of look the corner of like a room. Kind of see it better there. So that's an XYZ. They're planes. What happens here? Here's an XY. Here's a ZY plane. Here's an XY plane. Here's the XZ plane. So what happens with planes? Same thing happens with lines. You can have they all cross at one point right there in the middle. Then you have one solution, independent. Or they could all cross at infinitely many points, so that all these straight planes are crossing like a whole line there. So infinitely many solutions. Or dependent. They could be right this exact same plane, so like again infinitely many solutions. Or it could be no solutions. Now this happens in different ways. You could have, in this case, like X and Y cross, Y, Z cross, but they don't all cross at one point. So that's why there's no solution for all of them. Same thing here. Oh, these two cross, but they don't all cross. So there's not one solution for all of them. Or maybe none of them cross. So in this case, inconsistent. So now that we know that just like a 2D system, a 3D system also has one solution, infinitely many solution, no solution, let's go about solving it. So you can solve this, so in this case, this is a system of 3 equations. There's X, Y, and Z now. You actually go about solving it in lots of different ways. You could do substitution if you want, which in this case, personally, I don't think it's the best way. But I'm going to focus on elimination. I think that's the general best way of doing this. So here's the rule number 1 about doing this. We're going to do elimination. You got to eliminate the same variable twice. So I cannot stress that enough. Stress that out enough. A lot of times people go, okay, I'm going to get rid of the x's here, and then they get to the next one, like, ooh, it's actually a lot easier to get rid of the z's than this too. So they get rid of the x's and they'll get rid of the z's. Not the best idea. Get rid of the same variable twice. So that's what we're going to do. We're going to eliminate the same variable twice. And then once we do that, we're going to solve the 2 new equations to make more sense in a second. Solve the 2 new equations like normal. And then once you solve those, you go back, sub solutions in to any original equation to find the last one, to find the last variable. So hopefully this makes a little more sense once you're doing it. But the general idea is eliminate the same variable twice. If you do that, you can be fine. So let me name these. I like to name A, B, and C. So we got to decide which variable we want to get rid of. If you want a hint to what's there's actually I have no idea which one's going to be easiest, but canceling stuff out, Z would probably be the easiest because it's by itself. So I can multiply it by like 2 to get rid of this Z, I can multiply by 5 to get rid of that Z. But I don't know if it's going to make the rest of it easy. But let's get rid of the Z's because that does make it easy. So I'm going to do A and C first. So if I want these to cancel out, I'm going to multiply the bottom row by -5. So I multiply the whole bottom row by -5. So the first one, leave it alone. And Now it's so easy to make a small mistake, just forgetting a negative or adding a negative where it shouldn't go, and then you're just kind of messed up for the rest of the problem. We'll apply the bottom row by -5. So -5 times 5 is 25x. -5 times 3 is -15y. -5 times z is plus 5z. Remember, I do a negative because I want them to cancel out. I don't like subtracting. And then -5 times 17 is a positive 50 plus 35, so 85. Hopefully I did that right. So now you add them up. These cancel. I get 27x minus 11y equals, let's see, 103. So that's my first new equation. So box it, that's my new equation. 27x minus 11y equals 103. Now I gotta do it again. Now, again, the key to this is get rid of the same variable twice. So I got rid of z, so I gotta do it again. So I'm gonna pick c again because that's easy. I can't do it with a or did that, so I'm gonna do c and b. Again, the reason I'm doing c is because it has a z by itself. So I'm gonna multiply the bottom row by 2, and that should get rid of the z's. So I'm gonna keep b alone, b the way it is. And then I'm gonna multiply my c row by 2, so -10x, 6y, minus 2z, and -34. Again, so easy to make a small mistake. You got to really make sure you don't mess any little thing up. And we're gonna add. I get -13x plus 11y. Those cancel, and I get -61. I think that's right. So that's my other new equation. So once you get your two new equations, I go step 2. Solve the two new equations like normal. So I'm just gonna rewrite these so we have them right on top of each other. 27x minus 11y equals 103. -13x plus 11y equals -61. So I have this. Now all we're going to do here is solve like normal, just like a normal elimination substitution problem. So you're going to solve this like we did in section 3.1. I got lucky in this case because my y's cancel out when I add, and I just get 14x equals 42. And then I could solve that, divide by 14. I get x equals 3. So now I'm not done. Remember, solve like normal. So I have my x, plug it back into one of these to find your y. So y, I'll plug into the bottom one. So I gotta find my y. So -13 times 3, plugging my x in, plus 11y equals -61. -39 plus 11y equals -61. Plus 39 plus 39. 11y equals 39. Ooh, that is 32? 22. There we go. Divided by 11. -22 actually. So y equals -2. So I have x, I have y now, y is -2. Oh, now the last thing I gotta do is sub those solutions into any original equation to find the last variable. So I go back here, you plug it into any one you want that has a z, and then you can find the last one. I'm gonna plug it into the top one maybe, because that looks like the most positive numbers. 2x plus 4y minus 5z. 2x plus 4y minus 5z equals positive 18, I think. Let me double check. Yeah. Right, so then all we gotta do here is solve it like normal. So plug in, sub in the 3, sub in the -2, I get 6 plus -8 minus 5z equals 18. These are on the same side, so I just add. -2 minus 5z equals 18. Add the 2. -5z equals 20. Divide by 5. Z equals -4. So there's my x, there's my y. So that's how you solve it. And remember, your answer is a coordinate point. So again, so that's how you solve one of these. Let's do a couple more to make sure we got this. But it's always the same idea. Eliminate the same variable twice. Once you do that, you just solve your two new equations like you normally would. Once you solve those two, you go back, plug in your two solutions to any one of the original ones to find the missing one. That's the general idea. So let's do this next one. And this next one has a little bit of a twist to it. If you notice, this one right here, is already missing a variable. So what happens in that case? Well, you can treat it like normal. What I do is I move this onto the finals. I make this one of my new equations. Like it already got a first round bye. So what I got to keep in mind though, this is missing B. Right, so I'm gonna use that to my advantage. So in these two, I'm gonna eliminate B, so they match. Right? Again, this is if I'm gonna use this is missing B, so I'm gonna eliminate B here. Again, I don't know how to do this. I could do like normal. I could just get rid of the A's here, get rid of the A's there, and just treat like a normal problem. But if we want to use that to your advantage, it moves on to the finals. This is missing B, so you gotta get rid of B in these two. I'm not sure if that's the better way or worse way, but that's what I'm gonna do it. These are my equations. If I want to get rid of the B's here, I have to multiply the top by 3 and the bottom by 4. So I'm going to get 3 times my top equation, so negative 9a minus 12b plus 6c equals 3 times that is 54, I believe. Yeah, 28 plus 20 plus 28. Whoa, not 54. Whew. 84. Sorry. 84. And then we're going to multiply the second row here by 4, so the b's could cancel out. So I want the b's to cancel out. So 4a plus 12b minus 16c equals 4 times that. It's negative 124. Then we're going to add them up. These cancel. I get negative 5a, negative 10c equals negative 40. So I get that. Not bad. Now before I combine these, it's my new equation. If you notice, you can make life a little easier here. These are all divisible by negative 5. So if you want, you can make your life a little easier and divide all this by negative 5. And you're going to get a plus 2c equals 8. Again, you don't have to do this, but it does make your life a lot easier. So here's one equation, and here's my other equation. So let's solve those two like we normally do. Let's do it right here. 2a plus 3c equals 11, and a plus 2c equals 8. Again, I want to solve this, so let's multiply the bottom row by negative 2. I get negative 2a minus 4c equals negative 16. The a's would cancel. I get negative c equals negative 5. Also just c equals 5. So once you get one, don't forget to go back, sub it in, find the other one. You can plug it into any one of the two new equations, that one or that one, doesn't matter. So I'll use that one because it's right there. So a plus 2 times 5 equals 8. A plus 10 equals 8. A equals negative 2. So I have two of them. All I gotta do is go back, plug it into any one of the original ones to find my b. Well, I can't plug into that one because it doesn't have a b, but I'll use the middle one maybe. A plus 3b minus 4c. So I'm gonna plug it back into this equation. A plus 3b minus 4c equals, I think, negative 27 or something? Negative 31. Alright, so I'm gonna plug those back, both of those into here, sub them in. So I get negative 2 plus 3b minus 4 times 5 equals negative 31. This is negative 20. I can add those up. I get 3b minus 22 equals negative 31 plus 22. Now your book generally has all these work out nicely, so if you got a bad answer, you probably made a small mistake somewhere. It's so easy to make a small mistake. B equals negative 3. So there's my answers. A is negative 2, B is negative 3, and C is 5. And that's the general idea, right? Again, eliminate the same variable twice. In this case, I just use it to my advantage. Once you get your two new equations, just solve them like you normally would. And once you solve those two, just go back, plug it into any one of the originals. Okay, one more problem. We're going to skip this one, the same idea. Let's get down to this one. This one's a little different. So, we're going to start the same way. Let's do the same thing. This is ABC. I got to pick a variable to get rid of. I think Z again, because notice how Z is alone right there. So I'm going to eliminate Z. Remember, you got to do it twice. There we go. So let's do A and B together. So if I want these to cancel, I'm going to multiply my top row by 5. So 5 times 3 is 15. 5 times 5 is 25. negative 5z equals 60. Remember, multiply the whole row, even the 12, so that's 60. I'm going to keep the second row the way it is, negative 2x minus 3y plus 5z equals 14. I'm going to add them up. This is 13x plus 22y, gone, plus, equals 74. So I have that. So that's the first two. Now I'm going to do a again because as it's z I want, and I'm going to do a and c now. I already did a and b, can't do it again. So if I want these to cancel, I'm going to multiply a by 3. So 3 times 3 is 9x plus 15y minus 3z equals 36. Keep c the way it is. It's 38. So I get 13x plus 22y, these cancel, equals 74. And then now if you look at, they're the exact same thing. My two new equations are exactly the same. So I'm going to have 13x plus 22y equals 74. 13x plus 22y equals 74. So what happens here? Well, solve it, right? Let's subtract them or whatever. You're going to get 0 equals 0. That is a true statement. So remember, when it's a true statement, you get all row numbers. Or infinitely many solutions. Probably the better ones, infinitely many solutions. So if it was a false statement, it would be no solution. In this case, it's a dependent system, so infinitely many solutions. There you go.